All right, today we're going to talk about exponential growth and exponential decay. Now, we'll start out with growth. Now, to y'all, growth can be a lot of different things. It can be money growing in an account. It can be bacteria growing. It can be populations growing. Anything that's increasing. Now, it's going to be increasing exponentially. That means it's going to be increasing fast. So, all right. The basic picture for this, you with me now? The basic picture for this, like your parent graph, is going to look like this. It crosses at 0, 1. There's a reason for that, but we won't get into all that right now. All you need to know is it crosses at 0, 1. And it increases. It never crosses this X here, but it just kind of starts curving up. So it kind of hovers near the X until it hits that point, and then it starts slowly curving up. So this is the basic parent graph for this. Here's what the basic function looks like. That's your basic something to a power. Now, X has to be positive for it to be climbing like it is. So you'll have a function with a positive exponent to get this basic look. Now y'all know you can shift it up and down and do different things, but this is your basic. Okay? Alright, next we're going to look at the formula for this. The exponential growth model or formula. C, y'all got blanks here, so I'm going to give you what each one means. In this formula, C is called the initial amount. That's what you start out with. Could be the money, could be whatever. That's what you start with. R is the growth rate. Now, the growth rate will sometimes be given as a percent. Don't put a percent in there. Put a decimal. So, if it's percent, you need to make it decimal always. So we'll watch that. And then T is time, and time can be, it could be seconds, it could be years. It's whatever it is. So T is whatever the time period is. So we'll just be plugging in here. Okay? All right, so we'll go through, a lot of times they'll give you a situation. This situation is, they got newly hatched catfish. And they tell us that they weigh about 0.3 grams when they're born. And they're going to monitor for the first 42 days of life. And they say that it's increasing about 10% each day. So we want to find their weight about after 42 days. I'm going to copy down the formula again because I don't have it to look at. Y'all may. But I'm going to put it right here so I'll remember. So there it is. All right. So in this problem, what's C, my initial amount? 0.3 is what they started out. So C is 0.3 times 1 plus R is the rate. What's the rate going to be? 0.10, exactly. Move the decimal 2 to the left because you don't want to leave it 10%. So 0.10 raised to the 42. Right, because that is our time. So we will type that in. Somebody please type that in because, like I said, I could. It's what again? 16. All right, make sure y'all are good with that. What is that? What does that represent?
The weight after 42.
Good. This is the grams and the weight of the catfish after 42 days. They got to be chunky little suckers. They ate. So, and again, that's approximate, of course. Not every catfish is going to weigh that. Just the average one. All right. Good so far? All right. Let's do another. This time we got rabbits. Josh, you'll like this. Pay attention. This time we got rabbits. They're released into a wildlife region, 20 of them. And then they tell us that they triple every year for 5 years. We want to know how many rabbits after 5 years. Now I'm going to put this back up here. Okay. What is my C in this problem? 20. That is the how many we started with. Now, let me tell you before you go any further, if you look in this problem, we don't know a percent. So sometimes they'll give you percent like the last one, sometimes they won't. How fast are these rabbits growing? They're tripling. Okay, now don't go here yet. When they tell you it triples or doubles or quadruples, they don't give a percent, you don't look at this little growth factor, is what they call it, 1 plus R. You don't use that if it's not a percent. Instead, you think it's tripling, so I'll say 3. Doubling, I'd say 2. So you don't do the 1 plus R when they do triple or double or quadruple. You just put the number to the what? All right. So see about how many little bunny rabbits? 4. What y'all? 406.
486.
Okay, is that good? Okay, sorry. All right, so 4,860 little bunny rabbits floating around out there. Josh, I hope you got a lot of rabbit feed. Okay, so we're going to take this rabbit problem and we're going to merge off into the next thing we're talking about, which is exponential decay. So we talked about growth, it's growing. Now let's talk about decay. What if we take our guns and we start shooting bunnies? We start killing off the little bunnies.
That's dumb.
And then their bodies lay there and they start to decay. Why can't we just eat them? Well, we're going to measure the decay rate, that's why. All right, so now we're going to look at how it decreases. Hold that thought. All right, here's the decrease or the decay picture. Still going to be crossing at 1, but it's going to be going decreasing now. So it's going to start out and it's going to curve down and it's going to just hover. It's never going to cross the X. It's just going to get close to it. So there's how the decrease basic graph looks. This would still be a to the X, but X now would be negative. In other words, a negative exponent would give you that look. Will you stop it? We'll just stop it. We'll do. All right. So next to last. Now let's look at decay. Now, decay is where it's decreasing, going down. They could use a word for that: decrease, diminish, or decline. Anything that's going down. What's the only difference in this and the growth? It's subtraction instead of addition. The only difference is that. C, still the initial amount. You're right, you said decay rate. I'm sorry, it just clicked in. The R is decay rate instead of growth rate, and T is still time. The good thing about these problems, you're not going to have any of those double or triple or quadruple. They're going to give you a percent on these, okay? So let's do a decay one then real quick. All right, so we got a computer. We paid $1,800, and it depreciates. Notice, y'all. Notice. Here's our key word. That's like decreases. It decreases at the rate of 29%. We want to know how much it's worth after 2 years. All right. So here's what we're plugging into. All right. So what is my C, my initial value? 1,800 times 1 minus 0.29 to the 2. All right. And calculator, folks, this is money, so round it like it's money. Let me make sure I'm right. 907.38. Thank you. So check and make sure that's right. So this is about how much it'd be worth after 2 years. Y'all, it could be money decreasing. It could be bacteria dying. It could be bunnies dying. It could be the zombie bunnies. It could be anything as long as it's decreasing. Alright, last thing for us, besides knowing how to plug in for these, they might give you a already set up equation, notice, and ask you, is it growth or decay? So there's a couple things you gotta look for. Look, y'all be with me now. Some of y'all are not with me. Alright, so this number right here is important to us. This number right here, if it's gonna be growth, it needs to be bigger than 1. Because remember, it's 1 plus whatever. And if it's decay, it needs to be less than 1. So this number in parentheses here, if the number is greater than 1 and the exponent, I'm going to throw that in because we said it at the beginning, the exponent has to be positive. So if it's greater than 1 and the exponent is positive, it's growth. Decay, number is less than 1, and or, I'm going to say it this way, exponent is negative. Now I said and or because either one will make it be negative. So to be growth, it's got to be both of these. To be decay, it's only got to be one of these to be decay. So what is this particular problem? Growth. Now, if I'd have stuck a negative on that 5 exponent, that would have made it decay. So you're going to have to watch the number in parentheses. You're going to have to watch the sign of the exponent. Okie dokie. That's the last one, isn't it? All right, if you want to stop the